Good morning, respected faculty and my dear friends. I am Aditi Egote, and today I feel honored to present before you one of the most fundamental and fascinating subjects in engineering mechanics. Engineering mechanics is not just about equations and diagrams, it is about understanding how the world around us stands, moves, and survives forces. From bridges and buildings to machines and vehicles, everything obeys the principles of mechanics. Engineering mechanics is a branch of science that deals with the behavior of physical bodies under the action of force and movements. It forms the foundation of all engineering disciplines, whether we design a structure, analyze a machine, or study motion. Engineering mechanics helps us ensure safety, stability, and efficiency. Without a clear understanding of mechanics, no structure can be trusted and no machine can perform reliably. A force is any push or pull that can change the shape, direction, or state of rest of an object. Forces can be broadly classified into contact forces and non-contact forces. Contact forces act when objects are in physical contact, while non-contact forces act from a distance. To understand forces clearly, engineers often use force diagrams, which usually represent all the forces acting on a body. These diagrams are essential for analysis and problem solving. Now, let us look at some common forces encountered in engineering. Friction. This force resists motion between two surfaces in contact, and it is essential for walking, braking, and gripping. Tension: a pulling force transmitted through strings, cables, or ropes. Normal force: it is the support force exerted by a surface acting perpendicular to it. Gravitational force: the force that attracts objects towards the earth is gravitational force. Each of these forces play a crucial role in maintaining balance and functionality in engineering systems. In engineering, a load refers to any force or weight applied to a structure. Loads are classified based on how they act. Point load: a load applied at a single point is called as a point load. Distributed load is a load spread over a length or area. Dynamic load is a load that changes with time or motion, such as vehicles moving on a bridge. Understanding loads is vital to prevent structural failure. Let us further classify loads. A uniformly distributed load is a load that spreads evenly across a structure. A load whose intensity changes along the length is called as varying distributed load. Static load is a constant load that remains unchanged with time. Impact load is a sudden and short duration load caused by events like collisions or falling objects. Engineers must carefully analyze these loads to design safe and durable structures. Structures require supports to remain stable, and these supports develop reaction forces. There are three main types of support. Fixed support restricts all movements including rotation. Pin support allows rotation but prevents translation. Roller support allows movement in one direction while restricting vertical motion. Each support type behaves differently and affects how forces are distributed in a structure. To calculate support reactions accurately, engineers use force resolution techniques. A force can be resolved into components, usually horizontal and vertical, which implies analysis. Using free body diagrams, engineers identify all acting forces and apply equilibrium equations to ensure the system remains balanced. This step is essential for designing structures that can safely withstand applied loads. To conclude, engineering mechanics is the backbone of engineering design and analysis. We have studied forces and their types, loads and their classifications, support reactions, and force resolution. These concepts help engineers transform ideas into safe, stable, and functional structures. Mastering engineering mechanics allows us not just to build but to build responsibly. With this, I come to the end of my presentation. Thank you for your time, patience, and attention.